Oil spills are dirty, disgusting, damaging disasters. But don't worry, because scientists are going to start cleaning them up with fire tornadoes. Fire tornadoes. Hey hotties, Jules here for D-News. Fire is kind of a strange phenomenon. It's one of those things that human civilization has learned to both deeply love and deeply fear. It cooks food, it burns down cities. It creates light, it burns down property. It sanitizes, it burns down people. But unlike water or air or land, fire is distinct from the others in that it's an active chemical reaction, which is great because we can change one side of the reactive equation and change the nature of the fire. First of all, when I say that fire is a chemical reaction, I mean it in exactly the same way that something like rust is a chemical reaction. In fact, on a broad enough scale, rust is just a much slower, but almost chemically identical version of fire. See, because basically all fire is rapid oxidation. Oxidation is when an atom or compound loses electrons in a chemical reaction, which is pretty easy to explain using the example of rust. When something made of iron is exposed to oxygen atoms in the presence of moisture, the iron steals electrons from the oxygen. Now, the iron and oxygen have opposite charges, and much like Brittany and Kevin, opposites attract, converting the iron into a flaky reddish material called iron oxide, aka rust. The oxidation of fire occurs when those same oxygen atoms are in the presence of hydrogen, carbon, and intense heat. But the chemical reaction is so incredibly fast that it causes combustion, and all the energy generated by this chemical process is released in the form of heat and light. See, what you observe as fire is actually only a small visible portion of the reaction called a flame. Flames are mostly made up of reaction byproducts like carbon dioxide, which is carbon and oxygen, water, hydrogen and oxygen, oxygen and oxygen. Any smoke floating from the top of a yellow flame is unburnt fuel, also called soot. The more smoke and the more yellow a flame, the more impure it is, and that's kind of a big problem with fire. Combustion that produces byproducts is dirty, uses a ton of fuel, and leaves a mess when it's done. That's why cars run on gasoline and not twigs lit on fire and shoved into the twig tank. Gasoline burns much cleaner, is much more energy efficient, and leaves much less residue than a forest fire. The cleaner and more efficient we can make fire, the easier it is to work with, and the better it is for practical applications. One of the least practical versions of fire is a fire tornado, which is a raging whirlwind of unstoppable destructive energy, kind of like Kanye West. But recently, engineers at the University of Maryland found a way of turning a raging fire tornado into a small, pure blue, almost perfect fire whirl. To do this, they filled a pan with water, poured liquid fuel on top, lit it, and pulled cold air through the mixture. After some time, the 2-foot-tall bright yellow tornado condensed into a 3-inch tall blue flame, producing almost no byproducts at all and using the fuel source with very high efficiency. The engineers were looking for a new way to deal with oil spills, but the applications for such a useful flame are almost endless. Think of everything we use that relies on combustion, starting with planes, trains, and automobiles, not to mention gigantic rocket ships, tiny cigarette lighters, and industrial factories. Being able to use less fuel and leave no byproducts can save an endless amount of money, cut back dramatically on pollution, and make fire more controllable and, above all, safer. That said, the researchers have effectively no real idea as to why they got this blue whirl to occur or how long they can theoretically sustain it. But when science finally harnesses the power of the fire tornado, we're going to see a lot of changes in the way we burn. A cleaner burning fire can lead to cleaner burning cars, but we're not there yet. So watch this video by Julia and Julian about how car companies can cheat emissions tests.
It appears that instead of a urea tank that would need occasional refilling, they invested millions developing a NOx trap. It would soak up those chems like a sponge and spritz them with a bit of fuel for 10 seconds every 10 minutes, and voila! Clean air. But it hurts fuel efficiency and performance, so what was VW to do?
Any other questions about fire? Let us know in the comments, and don't forget to like this video and be sure to subscribe for more D-News every day of the week.